In Unit 2, we learned about rigid transformations. So some of the vocab we talked about, first of all, was symmetry. So symmetry is when an image matches up. So there's three different types of symmetry. Point symmetry is just when you turn the figure upside down and it'll look the same. So point symmetry is really the same thing as saying rotational symmetry, because you're just rotating it 180 degrees and seeing if it looks the same. Line symmetry means the figure is symmetric over a line. So basically, if you imagine folding the paper, if the image matched up on both sides, that would have line symmetry. And then rotational symmetry is you can turn the figure any number of degrees. So any number of degrees less than 360, because if you did 360, it would always come back to itself. So for example, if I had a square, this would have rotational symmetry of 90 degrees, because basically if I turned this square 90 degrees, it would end up looking the same because all sides are equal. So if you turned it 90 degrees counterclockwise, it would look the same, so you would say it has rotational symmetry of 90 degrees. You could also say it has point symmetry because you could turn it upside down and it would match up. You could also say it has line symmetry because I could draw in a line, like a diagonal line here, fold along that line and it would match up. So those are just kind of the different types of symmetry. Isometry was another vocab word. They don't use this so much anymore in the Common Core curriculum, but it could show up. So isometry is basically the same thing as saying a rigid motion or a rigid transformation. So these are also the same thing. So rigid motions, rigid transformations, those are other names for an isometry. So isometry means that you perform the transformation, but everything stays the same. The distance and length stay the same, as well as the angle measures. So isometries produce congruent figures, is what's the main idea there. So distance and length stay the same. Then we have two different types of isometries, so opposite isometry versus direct isometry. Opposite isometry only occur if reflections occurred. So reflections are opposite isometry because the order of the letters gets switched. So this is where I would look at a figure and I draw on arrows in alphabetical order and then compare the two sets of arrows. If they go in opposite directions, it's an opposite isometry, which is what reflections are. Direct isometries are going to be your translations and your rotations. And what direct isometries do is the order of the letters are going to stay the same. So the arrows are in the same direction. So this deals with the order of the letters. So the next set of words here, you have, these are all rigid transformations. That's what these are. They're rigid motions or rigid transformations. I'm just going to add that on here. So we have translations, reflections, and rotations. So translations, SL for sliding, so you're sliding a figure. Capital T is the notation. A and B tell you what you're adding to the X values and then what you're adding to the Y values. So this is your adding to A, or X, this is what you're adding to Y. And it's telling you how you're moving. So you're moving, your horizontal movement is this number. So positive means right, negative means left. Positive B value means up, and then negative means down, so that's your vertical movement. Rotations, the process for that is you always have to look at what the center of rotation is. That typically is the origin, but it doesn't have to be the origin. So wherever the center of rotation is, that's where you're going to start, and then you figure out how many quadrants you're moving based on the degrees that they're telling you to rotate. So that'll tell you how many quadrants. So using these rules right here, and then from there, from the center, you either keep the order or you flip the order of the horizontal and vertical movement. So that's important. We're going to go over an example of that, and so we'll talk more about it. We're going to talk about this in a minute. And reflections, when you do reflections, always graph the line of reflection, and then you just count however far it takes to get to the line. That's how far you travel from the line. If you see a reflection over y equals x and y equals negative x, these are the ones that people mess up with because the lines are, here's the line y equals x, it's a diagonal line, and then the line y equals negative x has a negative slope diagonal line, so the -1 is the slope. People mess up with these reflections because you have to count diagonally. You always have to count perpendicular to the line of reflection. So what I would do is just remember those two rules. If you're reflecting over y equals x, just switch x and y. If you're reflecting over y equals -x, we'll switch them and negate them. And then compositions of transformations. So if you see something like this, a reflection over the line y equals x of a translation of 2, -1, you always work backwards. So you start with this one, and then you do this second. So this would come second, and you always use the results from the first one. So second using the prime values. So meaning using what you get out from the translation. So let's try some examples with these. So the practice problems here, the first one says we have a translation that's taking p to p prime. So the first thing I would think about is if it's a translation, it means that you're going to be adding or subtracting numbers. That's what a translation does. Dilations is where you're multiplying, so translations where you're adding or subtracting. So it's asking us, how did we get from p to p prime? So what did you add? So if you look from 3 to 6, we had to add 3. And then from 5 to 1, we had to subtract 4. So that means the translation was a translation of 3, -4, meaning we moved right 3 down 4, or we add 3 to x, subtract 4 to y. So then it says, what are the coordinates of the image of the point, so this point here, under the same translation? So if I start with that point, -3, -5, I'm going to apply the same translation to it. So I'm going to add 3, so I end up with 0. And then I'm going to subtract 4, so I end up with -9, and that is going to be my new coordinate. So 0, -9 would be the new coordinate. Now you could have also done this on a graph. You could have counted how did I go from p to p prime, and then from there plot this point and just do the same movement. Either way, same answer. Remember, you'll always have graph paper available, so you could have done this on a graph. The next one here, we have this triangle, so let's start by plotting it. So we have -6, 5, so 2, 4, 6, up 5 is R. S is -7, -2, so 2, 4, 6, 7, down 2, and 1, 4. And it says find the image after a reflection over the line y equals x. So this is what we're doing. So as soon as you see that, there's two ways you can do this. You can do it on a graph, but you can also just switch your coordinates. So when you reflect over the line y equals x, you just switch x and y. Now, if it was y equals -x, you would switch them and negate them. So really, I can come up with the prime values without even looking at the graph, but I wanted to at least show you the graph as well. So I'm going to show you the graph in a second. So if I just use the rule, switch x and y, I look at these coordinates, I just swap them. So it's going to be 5, -6. Switch these. So -2, -7. Switch those, you get 4, 1. So these are the answers. Sometimes it might say find and graph the image. So in this case, if I had to graph this, I would just go and graph them. So I have 1, 2, 3, 4, 5, down 6, 2, 4, 6. I'm going to show you in a minute how you could have done this without the rule. So 2, 4, 6, 7. And then t prime is 4, 1. So here's my image. So if it said to graph it, you would have to have this. You have to have your coordinates. You have to have everything labeled. Make sure you're remembering the letters. But also, if you wanted to do this on a graph, all you have to do is graph this line. Y equals x. It has a slope of 1 and a y-intercept of 0. So basically, if I start at 0, go up 1 over 1, this is going to be my line. And then once you get enough points, I don't really need to connect all of them, but I do know that it's going to end up at corner to corner because this is a square graph. So if I kept going up 1 over 1. But basically, if I just make sure that I accurately draw in my line, passing through the origin, going from corner to corner, so here's y equals x. What you can do, if you didn't remember the rule, is you can count. So if I started at S and I count perpendicular to this line, so basically since this line goes up 1 over 1, I have to go down 1 over 1, or count from corner to corner. So there's 1, 2.5 corners. So then I do half, 1, 2, and that's how I get S prime. From R, it's 1, 2, 3, 4, 5.5. So half, 1, 2, 3, 4, 5. So you can see that you're getting the same answers because you're always moving perpendicular to the line of reflection. So this is 1.5 away, so 1.5 away to T prime. So that's how I could have done it graphically. I could have graphed y equals x. I could have counted diagonally. Once I got my triangle, then I could have listed the coordinates. So you could have just done it backwards. So either way is an acceptable way of doing this. Number 3 here, this is a composition. So it's asking you which single transformation is equivalent to this. So first you're going to do this one, and then this is second. So what this means is a reflection over the x-axis. So I'm starting at the x-axis, I'm taking every point and I'm traveling over that line. So C is going to go 1, 2, 3 to the line of reflection, so travel 1, 2, 3 from it. So when you do the reflections over any other line other than the diagonal lines, I would just count it. I wouldn't think of the rules. You can use rules if you want, but it's easier, I think, just to count. So from A over the x-axis is 8 units. So 1, 2, 3, 4, 5, 6, 7, 8. So go 8 more. 1, 2, 3, 4, 5, 6, 7, 8. And then, so basically I'm just negating the y values as the rule. So this is down 7, so then I go down 7 more. So 1, 2, 3, 4, 5, 6, 7. And then whenever you do a composition, once you do the second transformation, you always use your result. So using this, reflecting it over the y-axis. So reflecting it over the y-axis means it's going to come over here. So I go over 1, so go 1 more. That's going to be C double prime. B is going to be 1, 2, 3, 4. 1, 2, 3, 4. So essentially what I'm doing is negating the x values now. Over 1, go 1 more. That's A double prime. So there's your new figure. So it's asking you, how could I have gone from 1 to 2? So if you're not sure, one way that you can check is check your orientation. So if I draw on the arrows here, so going in alphabetical order, you can see that the orientation is the same. The direction of the arrows is the same. So that means it would be either a rotation or a translation that would map figure 1 onto figure 2. Whenever you do reflections, it changes the order of the letters, but if I do a reflection and then another reflection, it changed it and then it changed it back. So that's why the orientation's the same if you just look at 1 to 2. So it looks like the figure turned. So if I imagine connecting C to C double prime, and here's my center, you can see that it was a straight line formed. Same thing from A to A double prime, B to B double prime. So that means it was a rotation of 180 degrees. My angle of rotation was a straight line, so 180 degrees. So it'd have to be choice 4. Number 4 here, it says the vertices of parallelogram ABCD are. So I'm going to actually just sketch a picture of this one because otherwise I think it's going to be hard to visualize. So I have A is 2, 0. B is 0, -3. C is 3, -3. And D is 5, 0. So that's a little bit off. So 3, 4, 5. So it's not perfect. But here's my figure here. So it says, after you reflect this over the x-axis, so after this comes up over this line, how many points remain invariant? So this means stays the same. So stay the same. Invariant means not varying, so staying the same. So if you reflected this over the x-axis, B prime would come up here, 3 units. C prime would come up 3 units. A prime and D prime are going to stay right in place because they're on the line of reflection, so you don't have to travel anything. So those are going to be invariant points. They stayed the same. So there's two of those that are going to stay locked in position. So that's the answer for that one. The next one's asking you to draw the line of reflection. So line of reflection is really the perpendicular bisector between any pre-image and image points. So you really only have to do one set of points. You don't have to do all of them because it'll be the same line every time. So basically, if you connect any pre-image and image points, so if I connect from A to A prime, all I have to do is the perpendicular bisector of that. So let's take our compass, and we're going to go more than halfway whenever you do the perpendicular bisector. Draw your arc, and then go up to A, and do the same thing. Draw your arc, and then the line of reflection is going to be the line, I'm going to change the color of this, it's going to be the line that goes through those 2 points. I'm going to fix it so it actually goes through both of them. Here we go. So the line of reflection is this line, this red line here, because it's the perpendicular bisector of any pre-image and image points. You could have connected any 2 sets of points and you would have gotten the same line. So that's it for that one. Number 6, I'm going to bring this protractor down. Number 6, it wants us to find the center of rotation and the angle of rotation. So the center of rotation is wherever 2 perpendicular bisectors intersect. So it's where all of the points, where you're equidistant from all of the points. So this is the intersection of 2 perpendicular bisectors. You could draw in all of the perpendicular bisectors if you wanted, but really once you have 2, you know where the intersection is. So you don't need to draw in all these different perpendicular bisectors and get a crazy picture when you could just do it with 2 perpendicular bisectors. So what I'm going to do is I'm going to connect any pre-image and image points. So let's say I do A and A prime. I'm going to do the perpendicular bisector of that. So just like what we did above. So more than halfway, draw your arcs. And then connect this. So with your straight edge, connect that. So this here is the, if this was a reflection, this would be the line of reflection. But if I'm trying to find the center of rotation, and since this is a rotation, I need to repeat this process. So let me go ahead and just connect another set. So let's say I do F and F prime, and then do the perpendicular bisector of that. So I'm going to go from F, my line's a little bit off, but I'm going to make sure that when I do this, my points of the compass are right on. So then I can do my arcs here, go to F, do the arcs, connect these. So let me use a different color for this one. So I'm going to make this red. And then where that perpendicular bisector intersects with the first perpendicular bisector, which here's my first perpendicular bisector, here's the second, that's going to be the center. So this is the center of rotation. So that's equidistant from all of the pre-image and image points. And then the angle of rotation, so if you imagine, so let's take, I'm going to just highlight where the angle would be. So from the center to, let's say, F to F prime, that angle, that's going to be the angle of rotation. So I'm going to take my protractor and I'm going to place it so that the center of the protractor is on the center. Now this is going to be a little bit off because my lines are so thick here. And then I need to make the edge of the protractor line up with my angle. So trying to make this as accurate as possible. So there's the center, there's the line, and then you're just going to measure it. So from 0 to where the yellow line crosses. So it looks like it's about maybe 125-ish. So you're this is a little bit off because those lines are so thick, but I'm just going to say approximately 125. So the angle equals, and I'm going to say approximately, so you might have got a different measurement than that, 125 degrees for that. So I would just add in, it's approximately 125 degree rotation, and it would be clockwise because it's going from the prime, or to the non-primes to the prime, so it's going this direction. So approximately 125 degrees clockwise, or you could say a negative 125. So then for the last one here, we have a multiple step transformation that we're going to apply. So let's start with graphing these vertices down on the graph. So we have A is negative 3, 1, so negative 3, 1. Make sure you're labeling these as you graph. B is 0, 5, and C is negative 5, 7. So there's C. And then the first thing we're going to do is a reflection over the line x equals 2. X equals 2 is going to be a vertical line going through 2. So whatever the number is, it's a vertical line. So x equals 2. So go ahead and just draw a vertical line going through x equaling 2. Make sure we label this here. So y equals would be horizontal. They're always opposite whatever the axes are. So x-axis, x equals is opposite that. And then when we do the reflection, we're just going to count. So from C to the line of reflection is going to be 1, 2, 3, 4, 5, 6, 7. So go 7 more. 1, 2, 3, 4, 5, 6, 7. So there's not really rules for these. You really just want to know how to graph them. So over 2 to get to B prime. A prime is going to be 1, 2, 3, 4, 5 to the line. So go 5 more. 1, 2, 3, 4, 5. There's A prime. And then we record our coordinates for that. So let's go up top and just fill those in. So it's going to be 7, 1 for A prime. B prime is 4, 5. And C prime is 9, 7. The next one here is using a translation using this vector negative 10, negative 7. So this tells us left 10 and then down 7. Or you can think of subtract 10 from all your x's and then subtract 7 from all of the y values. Either way. So if we were to count on the graph, I'm using, so let's see what it says to use. It says graph and state this, the image of triangle A prime, B prime, C prime. So that means you're using A prime, B prime, C prime. So I'm going to use this, and I'm going to go left 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then down 7. So 1, 2, 3, 4, 5, 6, 7. So that would be A double prime. B double prime is going to be left 10. So it's going to be over at negative 6. Then down 7. So 1, 2, 3, 4, 5, 6, 7. C double prime left 10, so I'm over at 8 right now. No, I'm over at 9, so it's going to be over at negative 1. So I'm just counting left 10, down 7. So down 7 would be right here. Then we state those coordinates. So go up top here, state those. So again, if you look at the coordinates here, really what I'm doing is I'm just subtracting. So I take these, I'm subtracting 10 and then subtracting 7. Subtract 10, you get negative 6. Subtract 7, you get negative 2. Or you're just reading the coordinates from the bottom of the page. So there's that one. Part C is wanting us to find triple primes, which is the image of the double prime. So using the blue triangle after a rotation of 90 degrees counterclockwise centered at the origin. So for this one, I'm going to use the blue triangle. My center is at the origin, and I'm going 90 degrees. So 90 degrees tells me one quadrant. And then counterclockwise is the direction. So basically, this is my center of rotation, is at the origin. So here's my quadrant I'm looking at. So I'm going to take these 3 points and they're going to move counterclockwise, so they're all going to end up over here. And since it's 90 degrees, it's one quadrant, but you also switch the horizontal and vertical movement. So what that means is, starting at the center, if I count to C, it's over 1. So instead of going over 1, I need to go down 1 from the center. So that's going to be C triple prime. Then from the center to B, it's over 6 down 2. So that means I go back to the center. I switch that. I go down 2 over 6. Nope, sorry. Over 6 down 2 means down 6, switching it. Down 6 over 2. I didn't switch it there. So switching the movement. Horizontal 6 down 2. Now it's down 6 over 2. Then we go to A. It's going to be down 6, right 3. So that means you're going to go, instead of horizontal 3, you're going to go down 3, and then you're going to move right 6. So then that'll be A triple prime. So then if we record those coordinates, so A triple prime is 6, negative 3. B triple prime is 2, negative 6. And then C triple prime is 0, negative 1. And then the last part here is which one does not preserve orientation. The only one that does not preserve orientation is going to be any reflection that you do. So if it's a single reflection. So the only one that was a reflection is number 1. So translations and rotations preserve orientation. It's reflections that don't.